Fixing slow performance is one problem, but sustaining great performance is another. We'll show you how to use function regression issues to debug a backend regression and connect it to the line of code causing the problem. This is an example of a function regression issue that was caused by a real regression in Sentry's backend. We can see this function, Redis rate limiter.isLimitedWithValue, had about a 50% increase in P95 duration. In the duration chart below, you can see where we think the regression occurred, along with how the function was performing before and after the regression. You can see here there's a pretty clear change in P95 duration right around this time. If we look at the throughput chart below, we see a clear correlation. The throughput after the regression was higher than the throughput before the regression. This suggests that increased load might be one of the causes of this regression. Below this, you can see a list of API endpoints that were impacted by this regression. That means that all of these endpoints somehow end up calling through to Redis rate limiter.isLimitedWithValue, which means that their durations are impacted as well. In this first endpoint, you can see that its P95 duration has regressed from 330 milliseconds to 458 milliseconds as a result of this function regressing. Next, we have sample profiles that were captured before and after the regression. We can compare these profiles to understand what changed and what caused the regression. So let's do that. I'm going to open up an example of a profile that was collected before the regression. Here you can see the regress function is highlighted and it's called twice. The first call takes about 300 milliseconds and the second call takes about 1 second. Above the functions, you can see from the span data the Redis operations that were executed in order for these functions to be called. Now, taking a closer look at the leaf functions that this function calls into, we see two notable functions. The first one is connectionpool.getConnection, and the second one is connectionpool.release. You can see that both of these functions are called both times that Redis rate limiter.isLimitedWithValue is called. Going back to the issue page, I'm going to open up an example of a profile that was collected after the regression so we can compare. You can see here the same regress function is highlighted, except this time it takes 2.8 seconds, which is significantly longer than it took before the regression. We can also see one of the same leaf functions, connectionpool.getConnection. And if I scroll to the right a bit here, I can see the second leaf function as well, connectionpool.release. However, this one takes 11 milliseconds, so it's likely not relevant to the regression. Now, focusing back on this leaf function, we can see here that it takes 2.79 seconds, which again is much longer than it took before the regression. So from this, we can infer that this function has something to do with why this regressed. From the source annotation here, you can see where this function is defined, which is in the Redis module inside connection.py on line 1177. So for convenience, I've opened up that source code here. Here, that exact line of code is highlighted, and this code attempts to acquire a lock. From this, we can infer that there are multiple tasks trying to acquire this lock at the same time, leading to lock contention, and that this lock contention is the reason for our regression.